The next section moves into naming. Okay, so whenever you see formulas with the di, tri, hepta, penta words, the prefixes, okay, like mono, di, tri, okay, and so on, that means you're working with molecular, or what's called covalent compounds. Okay, so that means you're using nonmetals with a nonmetal. Okay, so if you're looking at sulfur and fluoride, okay, fluoride, which is made out of fluorine, let's take a look at where they are. Sulfur and fluorine. Those are both nonmetals. So that's going to be a molecular compound. Okay, from there, you know that it's okay to use these prefixes. So based on that, how many is that? How many atoms of sulfur? Di means 2. So how many atoms of fluorine are we going to use? 2. Okay, so let's see which one has 2. 2 of each. 2, 2. There it is. Okay. In this case, we have a metal and a nonmetal. Okay, so oxygen is our nonmetal. Okay, and iron is our metal. Okay, so metals and nonmetals, those are going to form ionic compounds. Okay, and when naming ionic compounds, you start with the actual element, okay, and figure out the charge. Okay, so usually oxygen is going to it's going to gain 2 electrons. Okay, so it's going to have a 2 negative charge. Iron can sometimes gain 2 and sometimes gain 3. So we need to take a look. Okay, so iron can either lose 2 electrons or gain 2 electrons. Okay, I think I said it backwards the time before that. Okay, so iron could either be 2 or 3. So let's take a look at what our answers are and what's going on here. Okay, so it says in the question that we have iron and there's 2 atoms of that, and oxygen, there's 3 atoms of that. Okay, so if we were to use iron 2, okay, we would swap and drop, and we would end up with those charges being balanced. Okay, so we would end up with 2 atoms of iron, 2 atoms of oxygen. Okay, but we don't need to repeat ourselves with 2 of each, so we would transform that into iron and oxygen like that. Okay, is that what's on our list? No. So let's try it with the iron 3. Oops, sorry, my hand's in the way. Iron and oxygen. Okay, now let's swap and drop. Okay, so from there we get iron, sorry, this is supposed to be an E, iron 2O3. Is that the right one? Yep, same thing. Okay, so what would we call that? Is it diiron trioxide? No, because that's molecular compound. Okay, and we have an ionic compound here. We have metal and nonmetal. Okay, so we can't use that. Same with this. Okay, this is talking about molecular compounds. It has the tri in there, so it's not that one. Okay, so we had to decide, was it iron 2 or was it iron 3? Okay, and based on our figuring over here, okay, we know that we needed to use the iron 3 oxide. Okay, there's that one. Okay, and look at over here, the nitrogen and bromine put together. Okay, so we have nitrogen, nonmetal, bromine, nonmetal. Okay, so this is going to be one where we use the prefixes. Okay, because it's molecular. Why is it molecular? Because it's 2 nonmetals. Okay, so the first word, right, there's only one. Okay? And if it's the first word, we don't use mono. That's just one of the rules we needed to memorize. Okay, so it had to be nitrogen something. So far it's one of these three. Okay, now bromine. Okay, we have 4 bromine atoms. Okay, we need to show that. So this isn't going to work because it doesn't show that we have 4. We need something that's going to tell us there's 4. Okay, here's one that says there's 4. Here's one that says there's 4. Okay, and this is usually done for iron, nickel, cobalt. Okay, these are usually done for metals. These are usually ionic compounds. Okay, where you see the 3. Okay, so it's not going to be that one. And we already crossed out the mono here. So the tricky part in this section was just remembering that when it's the first word and it's only one of them, we don't say mono. Okay, so it would be C. To give you a different example, let's pretend we had carbon. Let's go with carbon monoxide. Okay, so we don't say monocarbon monoxide. Okay, we just say carbon monoxide. Okay, because we know that means there's only one at the beginning. Okay, aluminum. Going back to the same process for number 15. Okay, you need to figure out the charges for aluminum and bromine. Okay, so bromine, we have 1 minus charge. Okay, so we have bromine. Okay, and aluminum, what was the charge on aluminum? Okay, that's a 3 plus charge over here. Okay, so we need Al, 3 plus. What are we supposed to do? Swap and drop. Okay, if you'd like a more detailed explanation of why we swap and drop, okay, I have a different video that you can take a look at. But this is the easy way to remember it. Okay, so Al, how many do we have? Only 1. Okay, so Al, 1 of them. And bromine, 3. Okay, so we lose the charge on the way down because this is how many bromines we need. So to balance out that charge, you would need 2 electrons. Right, so 3 electrons got taken away. How many bromines do you need to take them all away? You need 3 of them. 1, 2, 3. So how many alumines do we have? 1. How many bromines do we have? 3. Okay, and we don't write the 1 when there's only 1. So we just call it AlBr3. So is that one of our options? Let's take a look. AlBr3. There it is.